when it comes to gravitational effects on time, what we see is that if you move faster relative to something else, time passes differently for the two of you.
It's slower, right?
Yeah, but who's really moving? Right? So Right. So it's different is the key point. If you're at a high altitude above the earth, time is moving differently from you as comparison to where you're near the earth. So if you put both of those together, what it says is that when your energy situation is different, your time's passage is different. The thing is that, it's all relative is the point. It's all relative. There is no zero-ness as regards this passage of time. So, for example, we use phrases like the age of the universe. There is no such thing. Why? You just said it. There are these huge voids that almost have no galaxies that are like 100 million, 150 million light years across. Then there are areas where they're packed with galaxies, right? So guess what? Time passes differently in galaxies and in galaxy clusters and in galaxy filaments than it does in these big voids, right? So the voids are older than they're moving through time more quickly than the galaxies are. Take Pluto out there, right? It's moving through time more quickly than the sun is, right? Yeah. So time is local. Time is something that you have, and what determines that rate of time is a difference in energy. If you boil it down, right? Gravity is another way of saying curvature of space-time, which is related to matter energy density. Speed is a way of saying kinetic energy, right? So, it all comes back to energy.
And this quantum field is not dependent on any of these, though.
Well, they are, because they do have time-varying properties, and they can have energy imbued within them. And so, for example, when you watch, like one of the questions I love to ask people over the years, because I never heard anyone else say it, is where does light come from? And people will often say the sun. And I'm like, okay, we're in this room. There is no sun, but yet there is light. And then they'll say energy. And I'm like, no, light possesses energy. The simple answer to where light comes from is matter makes it. And when when matter makes light, the identity of what the matter is and what it's doing is encoded in that light.
When you were talking about time, right? Like time technically moves slower for you, or your time moves slower if you're closer to the earth than at altitude, or if you're the one staying still and someone's running, right, relatively.
Yeah.
But what does quantum have to do with that?
Right. So energy moves between these quantum fields. So every time matter is emitting light, remember, electrons are a manifestation of a quantum field. Protons and their quarks, they're manifestations of quantum fields. So basically, the energy does not like the universe does not like energy to exist in the matter quantum field, right? So gravity is squeezing the energy out of the matter quantum field, sending it into the electromagnetic quantum field. Look up at night and you see it happening, right? All these collections of matter are just like, even you're doing it right now, right? You're emitting infrared light. And if it wasn't for your life process, you would grow cold and come to equilibrium with the environment. So the quantum fields move energy around, and so they have time dependent behaviors, and they have energy embedded in them. And these energies manifest as particles. And there's also a thing called the 0 point energy, kind of like if you were looking at a still pond. It looks perfectly flat like glass, but if you look at it with a microscope, you'll see that it's seething down there at a very low level.
Yeah.
These quantum fields do the exact same thing, and we call those virtual particles. So everywhere in you, outside of you, everywhere, little virtual particles are popping into and out of existence all over the place, right? So there is no nothingness and there is no energylessness, because you can actually borrow energy from the nothing to create something as long as you give it back to nothing in a fast enough time.
Because matter and energy are neither created nor destroyed.
Not true. They told you that, but they lied to you. Yes.
They lied to us.
I have so many questions rooted to this assumption, so please tell me the lie.
Well, you've heard of Star Trek?
Uh-huh.
Yeah. How does the Starship Enterprise power itself?
Well, I've never seen it. Okay, you tell me.
This is blasphemy. All right. So
we both have homework for tonight. We're going to go watch Star Trek.
Right? They use what is known as a matter-antimatter conversion chamber. All right. So when matter meets antimatter, they annihilate. So all of that energy that's in those matter and antimatter quantum fields leave. The matter's destroyed, never to exist right? And it becomes light. All right. In the same way, if you go Google bubble chamber experiment, you will see this experiment where a high energy particle of light, right? So energy is related to mass via E equals mc squared. So if I take the mass of electron, it has about half of a mega electron volt of mass energy. So if I have more than one electron volt of mass energy, right? Two electrons worth, I can convert that energy into an actual electron and its antiparticle that we call a positron. And the bubble chamber experiment, which goes back to the early 20th century, is pictures of that process happening, right? You see that you have a magnetic field. When a charged particle moves through the bubble chamber, it leaves a trail of bubbles. What magnetic fields do to charged particles is it changes their direction of motion. So the photon comes in, that gamma ray, it does not have a charge, so it doesn't leave a trail. But when it passes next to a neutron or a proton, that is what it needs, because it's a thing of energy and momentum. It has to give some momentum to the proton or neutron. Now suddenly you have a matter antimatter particle created, and you see them spiral in opposite directions. So you get these a vertex with two spirals coming off of it, right? So I just showed you. I created matter and I destroyed matter right there.
But from energy, right?
Okay, I'll give you another example. The universe is expanding, right?
Yes.
There's this thing called gravitational potential energy. Here, I take a thing and I lift it. It has more gravitational potential energy. Well, guess what happens when the universe expands? All these galaxies, there's now more gravitational potential energy in the system. Another thing that happens when light travels through intergalactic space, you've heard of cosmological redshift. That is the fact that the wavelength of the light is tied to what we call the metric of space-time. So as space is expanding while the light is traveling through it, that light gets stretched out by the same amount space expanded. And so the light goes to a longer wavelength, which means it has less energy. Where did that energy go?
When you say where did that energy go, do we know for a fact that it died, or do we just not know where it went?
All right. So if you go into the gory details, physicists argue about this. Is the energy, is this a violation of conservation of energy, or is it not, right? You got to look that up yourself, because there's arguments on both sides. But it's an example that appears to be a loss of energy in the universe in a particular way.
Okay, wow.
I just I'm so glad we're video recording this, because my face hasn't moved from just oh my God, the oh my God expression this whole time.
I tell you, learning physics and traveling the world, I've been to 44 countries so far, has taught me one thing. Half the narratives are complete BS. They're not real, right? If you study history, if you study the different places around the planet, if you study the way the universe actually works, all this stuff that the adults and teachers put into our mind, it's all simplified, and it's not, it ain't really truth.
Well, because I imagine truth is so hard to you're going to give 4-year-olds an anxiety attack Charlotte over here.
Exactly.
So we can't be doing that, So what level of complexity do you get to before you have to okay, this is where we have to pause.
Before someone has to be checked into an institution.
And it's happened, right? People lose their minds over this stuff.
And so you must just move through the world. What you see a shooting star, it's a cloudy day. You must absorb the world differently than you
can't unsee it. It's just like being a media person, right? So my first entry into media was around 1999. I started doing voice acting, right? I started taking classes, and one of the companies I did a lot of work for was MTV. All right. So I did about 5 jobs before them. And then one day I show up and they're like, "Oh, Hakeem, we never played your stuff for you. Here, listen." And I listened to it, and I realized why I gave them 3 takes and 3 different voices, or 5 takes and 5 different voices, because they snip it together, they layer it. And suddenly, when I hear music and I hear television, I can't unhear the editing, right? I know it's edited. Once I did this show, Baking Impossible, reality cooking show, right? Competition. And once I did that show and saw what really is happening versus what shows up, now you can break these things apart. And it's the same way with the universe, right? Once you see under the hood, you can't unsee it, and you see things completely differently.